Hello viewers, this is my first video on YouTube and today I am starting a discussion on geometry, congruence and parallelism. Hope you enjoy this discussion and learn something from it. Today I am presenting for you 5 very standard questions recommended for Olympiads, and you must solve it by pausing the video. I would like you to participate in by commenting me the number of questions you could solve yourself at the end of the video. I am starting a quick introduction of congruence and parallelism. The problems in this section present applications of several topics that are encountered early in the formal development of plain Euclidean geometry. The major topics are congruence of line segments, angles and triangles, and parallelism in triangles and various types of quadrilaterals. I will start with the questions now only, and as you solve we will get to know some properties along with it. Let's start. This is my first question to you. It says, in a right triangle ABC, CF is the median drawn to hypotenuse AB, CE is the bisector of angle ACB, and CD is the altitude to AB. You have to prove that angle DCE is equal to angle ECF. I have provided you with the diagram. Now you may solve it by pausing the video. I am waiting for a few seconds. Then I will start solving the question. I am starting with the solution. It is given that BF is equal to FA since AB is the median. CF is the median to AB. Now you know that the circumcenter of a right angle triangle lies on the midpoint of hypotenuse. Hence F is the circumcenter here, and since F is the circumcenter, FC is equal to CA. Therefore, angle FCA is equal to angle FAC by isosceles triangle theorem. Now, angle BAC is complementary to angle ABC. Similarly, angle BCD is complementary to angle ABC. Hence, we can say angle BAC is equal to angle BCD. Hence, this angle is equal to this angle. And since CAB is equal to FCA, therefore angle BCD is equal to angle FCA by joining equation 1 and 2. Done. Therefore, since BCE is the angle bisector of angle ACB. Therefore, angle BCE is equal to angle ACE. If we subtract angle BCE minus angle BCD is equal to angle ACE minus angle BCD. Therefore, we can tell angle DCE is equal to angle ACE minus angle FCA is equal to angle ECF. Hence, proved. Hope you understand the solution. Wait. This is the final solution. You may take a screenshot of this solution for further reading. Now I am proceeding to a next question. This is my next question. It says there is a square ABCD with angle EDC is equal to angle ECD is equal to 15 degree. Prove triangle ABE is equilateral. The previous solution went out of the screen. I regret for the inconvenience. This time it will not happen. You may try this question by pausing the video. I am waiting after a few seconds. Then I will start the solution. I have drawn a construction in this video for you to understand it. It's a perpendicular line from E to DE. You may proceed with this construction. Now I am starting with the solution. Draw a line from point D such that ED, and let the point G, angle EDG be 60 degree. There is a reason for it being 60 degree. We will know when I will end the solution. Now take this is 150 degree. This is again another 150. This is 15 degree. This is 30 degree now. 60 and 30, 90 because it's 90, and this is again a 150 degree, and hence this is again a 15 degree. Now see triangle. In triangle AGD and triangle EDC. See, this angle is equal to this angle. This line, length of this line AD is equal to DC, and this angle is again this angle. This proves that these two triangles are congruent. Hence I can write these two triangles are congruent by removing these. These triangles came congruent. Now we can see DG is equal to DE. It needs to be AG is equal to DE, but since it's a 15-15 isosceles triangle, hence we can say DG is equal to DE. Now if you know trigonometry, it says cos 60 degree is equal to half of the line. Hence, if we take cos 60 of this line, it will come DF, which is equal to half of DG. This is the reason why I used 60 degree. Now, it is half of DG. Then its DF is half of DE, we can say, because DG is equal to DE, it's E. Hence DF is equal to FE. This is the conclusion I get. These two lines are equal. Now I will say triangle ADG is ADF is congruent to triangle AEF. How? Because these two lines are equal, this line is common, and these two angles are 90 degree. Then we can say they are congruent by SAS rule, and these are congruent by ASA rule. Now, since these are congruent, by CPCT we can say AD is equal to AE. Similarly, by applying the same process on triangle BEC, I will get BE is equal to BC. Now, and since ABCD is a square, AD is equal to BC is equal to AB. Now, AD is equal to AE, BC is equal to BE, and AB remains AB. These are the sides of the triangle ABE. Hence, it is proved that triangle ABE is equilateral. Hope you understand the solution. I am proceeding to the next question. You may take a screenshot for further reading. This is my third question. It says, in a right triangle ABC with right angle at C, BD is equal to BC, AE is equal to AC, EF is perpendicular to BC, and DG is perpendicular to AC. You have to prove that DE is equal to EF plus DG. Pause the video and try it out. I will wait a few seconds now, and then starts the solution. I am starting with the solution. There are a few constructions here, like we have to join CD and CE, and then draw a perpendicular here on AB. These three constructions we need to do. Now, ACE is isosceles triangle. Therefore, angle CEA is equal to 90 degree minus angle ECB. Done. Then this is also 90 degree, and it's again, and angle CEA is again 90 degree minus angle, let it be something H is not there, HCE, because it's there 90 degree. Therefore, we can tell angle ECB is equal to angle HCE. These two angles are equal. This diagram is not to scale at all. Okay, no problem. Let it be. Now, this angle is, I will say, triangle HCE is congruent to triangle CEF, because this two is 90 degree, this is the common side, and these two angles are equal by, this is the proof. Hence, these two triangles are congruent by AAS congruency. Similarly, triangle, if we draw another, if we do the same thing here also, we will get these two angles are equal. And similarly, I can say a triangle HDC is HDC is congruent to triangle CDG. Now here we get the conclusion HE is equal to EF. Here we get DG is equal to DH by CPCT rule. Now if we add those, HE plus DH is equal to EF plus DG. It comes DE is equal to EF plus DG. This is what we need to prove. Hence we write hence proved. Come to the fourth question. You may take a screenshot of the question. This is the fourth question. It says, in a triangle ABC, BE and AD are the altitudes. FGK are the midpoints of AH, AB and BC. Remember, it's AH, not AD. It's AH, respectively. Prove that the angle FGK, it must be 90 degree. You may solve this question by pausing the video and waiting a few seconds. Then I will start with the solution. I'm starting with the solution. You all must know the midpoint theorem. It says if in a triangle a line joining the midpoints of two adjacent sides is parallel to the third side and it's half of it. You must know this, and we have a huge application of it here. It says G is the midpoint of AD. AH is the midpoint, H has a midpoint F. Both are midpoints. The line joining them is parallel to this. Hence we can say this line GF is parallel to BE. Now G is the midpoint of AB, K is the midpoint of BC. Hence this line GK, it is again parallel to AB. GK is parallel to AB. This is 90 degree. Hence we come to know this is also 90 degree by corresponding angles. If this is 90 degree, this is again 90 degree by vertically opposite angles. If this is 90 degree, this is again 90 degree by co-interior angles. These three properties of parallel lines you must know. I am writing these things for your convenience. This is the final solution. I have written all these. You may take a screenshot for further reading. I am starting with the fifth question. This is the fifth question. It says, in a parallelogram ABCD, M is the midpoint of BC, DT is drawn from D perpendicular to MA. We have to prove that CT is equal to CD. I have drawn the diagram for you, and you may solve the question by pausing the video. I am waiting for a few seconds, then I will start the solution. This is the last question today. After that, you must not forget to comment to me the number of questions you could attempt. If you couldn't attempt any, you must comment that also, because I will understand and then decrease the difficulty level of the question. It matters for all, I know. But if you couldn't solve any, you don't get regretted, because these are all RMO level questions. If you could solve at least even only one, you are very sure to get very good score in other Olympiads. Now let's start with the question. There is a construction here. We have to draw. Here is the R, the midpoint of AD. We have to join CR and extend it to TD to meet it at, let's say, P. Now see the quadrilateral ARCN. This is parallel, MC is parallel to AR and it is also equal to AR. This property holds even if and only if ARCM is a parallelogram. Hence I can write ARCM is a parallelogram. This is the symbol for parallelogram. Hence CR is parallel to MA, which gives CR is parallel to MT, which gives CP is parallel to MT, and eventually it gives RP is parallel to AT. Hence I write RP is parallel to AT and R is the midpoint of AD. Hence coming to the midpoint theorem, it says this is parallel, this is also a midpoint. Hence P is also the midpoint of TD. P is the midpoint of TD by midpoint theorem. Now AT is parallel to RP, it's told. Hence by co-interior angles, angle TPC is equal to 90 degree by co-interior angles. Now we will say triangle TCP is congruent to triangle DCP because these are equal, this angle is equal, this is the common side. By SAS rule, it's proved that these two triangles are congruent. And since they are congruent, it is told by CPCD that CT is equal to CD. This is the thing to be proved in the question. Hence I write, hence proved, as this is the final solution. Now I request you to comment me the marks you got. Each questions, I think it should be like of RMO pattern 17 marks, but I give you, it is of, I want you to answer only in 5. That is, you could correctly solve 1, then you write me 1. And okay, I will end the video now. You may take a screenshot for further reading. I am closing the video.